And let's do this problem and see if there are more problems which arise after this one. So if you look at the problem which we have at hand, is from the 2022 exam paper. Let me make my screen to appear this way. Okay, so let's quickly zoom in. If you look at the problem, it is from the 2022 November paper, and essentially it is on matrices. And all of you should make sure that you are able to deal with matrices. So let's look at the first question. They are saying, for what values of A will the system have a unique solution? And we are also speaking of Crammer's rule. So let's quickly rewrite that system as a system of equations. So I will say for A, let's write the system in matrix form. The system of equations. Matrix form. So if you look carefully, we have our x1 minus 3x2 plus 3x3 is equal to 4. And then if you look carefully, we have 2x1 and then plus ax2. Since we do not see any x3, it means it is 0. x3 equals minus 2. Let's go for the last one. We have 4x1. We don't see any x2, meaning it is 0x2. And then minus 3x3. This should be 0. So we can now write this in matrix form, and it will be on the first column, we'll write what is multiplying x1. So I'll write them in this order. We'll have what is multiplying x1, what is multiplying x2, and what is multiplying x3. So if we look at the first equation, we have 1, we have minus 3, and then we have a 3. And let's look at the second equation, which is this one. We have a 2, we have a, and then we have 0. The third equation, we have a 4, we have a 0, a minus 3, and after the equal sign, what we have is 4 minus 2 and 0. Do we all understand? Okay, let's go to the next page and see exactly what we are expected to do. Remember, what we are trying to solve is for what values of A will the system have a unique solution. So once we have written this, we need to do Gaussian elimination. If you remember, ideally, so say we need to do Gauss elimination. Remember that ultimately what we are looking for ideally is a 1, 0, 0, and then 0, 1, 0, 0, 0, 1. Then this will be equal to whatever the values are. Okay, then we can be able to read off our answers. So which means the first thing we need to do is to eliminate that 4. And the question is, how can we remove that 4? Anyone in the meeting? And how can we remove that 2 using row 1? It would be easy, good people. How do we remove the 2 there using row 1, and how do we remove the 4? Are we still there?
Sir. Sir, can you hear me?
Out in here.
To eliminate 2, you can multiply row 1 by -2 and add it to row 2. And to eliminate 4, you should multiply row 1 by -4 and add it to row 3.
Point plus row 3. And it's very important that the operation you are making is parallel to the row which you are making the operation. We don't write these randomly and put them anywhere. So please make sure you note that the operation, this is acting on row 2, that's why it's on row 2. This is the operation we are performing on row 3, that is why it is on row 3. So let's proceed and perform that operation. Row 1 remains untouched. And then row 2 will become 0. And we set -2 times row 1 plus row 2. If you look carefully, -2 times -3 will get -6 plus A. So -2 times -3, it will be 6. So we have 6 plus A there. And we have -6 plus 0, which is -6. And then we go to our row, the last row. We'll get a 0 here when we multiply 1 by -4 and then add a 4. And then we'll look at the second term, which will be -4 multiplied by that. That will give us 12. Then 12 plus 0 is 12. And then we can look at the last part, which will be -4 times 3, which will be -12, plus -3, which will be -15. Then let's quickly deal with the right-hand side. We have a 4. So for row 2, we did -2 times row 1, which will be -8. And then plus my row 2, it will be -10. The last row, we said we are doing -4 times row 1, which means -4 times -4, which gives us -16. Then plus 0, we have -16. Okay, there we go. And that's the answer which we find. And now we need to try and simplify this further, or at least think carefully what we should be doing. So what should we do from here? Anyone?
So can't you try and eliminate the 12 there by using, I don't know, like by using maybe row 1 so that we have a unique solution?
So now what we need to eliminate is that, because if you look there you go, we have a 0 there. So we need to think carefully, how can we eliminate the 12 there? We need to think really carefully and hard. So let me help you there, because remember what we are trying to do is to have that as a single row. So what we can do, think of this carefully. When we eliminate the 12, we can't use row 1 anymore because that 1 will come here. Do you understand? Because if we multiply the 1 by any number, another number will appear here, and we have done a lot of work to remove those numbers. Does it make sense?
Yes, so you can multiply row 2 by -2 and add it to row 3.
Multiply, and then we will have the A. And then we'll still need to do work on how to eliminate the A. Please go ahead.
Can't we just multiply row 3 by 1 over 12 and then we interchange the rows? Row 3 become row 2 so that we have 1 where there was 6 plus a. And then row 2 become our row 3.
We are allowed to interchange rows. So your suggestion is on point. So please remember that you can interchange rows. Because when we interchange the rows, when we divide by a 12, their life becomes easy. We easily get that one which we are looking for. So let's quickly do that. So we'll have 1 minus 3, 3, and then 0, and then we'll have our 12 minus 15. And this will be equal to my 4. I switched those rows, so I should have negative 16, and then minus 10, 0, 6 plus a, and then minus 6 here. Okay, and then if you look carefully, we can easily get a 1 here, which would make our life to be easy when we want to do the operation. So what we can do is we can do row 2 divided by 12. Let's go ahead. We'll have our 1 minus 3, our 3, 0, 1. Dividing by 12, we'll get negative 15 over 12. Then the other one remains as it is, 6 plus a minus 6 equals, we have a 4, negative 16 over 12, and then we have minus 10. Okay. Now we have the other one here, we are happy because now we are getting closer to what we are looking for. So we now have ones here. We are missing the other one. Now we need to make that to be a 0. How do we make that to be a 0? Because we don't want anything there. Anyone in the meeting, how do we make the 6 plus a to be a 0?
We can say that R2 multiplied by minus 6 minus a and then plus R3.
On point. So we can do negative 6, negative a multiplied by R2 plus R3. This is what you are saying.
Yes, sir.
And if you perform that operation, we will get exactly that 0 which we are looking for. 1 minus 3, 3, and then 0, 1. That will be negative 5 over, let me see, negative 5 over 4. When you divide negative 15 by 12, the common 3 there. Then this will be equal to 4, and then minus, there will be a 4 over 3. And then let's do the operation. So we'll get a 0, a 0. And now what we said is we are multiplying our row 2 with our negative 6, negative a. So our 15 there, it will become, sorry, this here, it will become a positive 5 over 4. The negative, which comes from the 6 and the a, will multiply with that. So we'll have 6 plus a. And then we are adding what was on row 3, which is minus 6. You agree? We all understand.
Yes, sir.
Okay, point. And then we do exactly the same for the other one. So we have minus 10 multiplied by minus 6 minus a. No, I must multiply the top one, which is from row 2. It is minus 4 over 3 minus 6 minus a. Then I add what is on my row 3, which is minus 10. Okay, quickly try to simplify these and see what answer we are getting. So we need to combine them. So as minus 3, the 3 equals Here I have a 0, a 1, negative 5 over 4. Then I have a 4, negative 4 over 3. I have my 0, 0, and then I want to combine these ones so that I have a common denominator. So what are we going to have? 5 times 6, that will be my 30, and then plus 5a, and then 4 times 6 will be 24. So we have minus 24 over 4. Do we have anyone who has a question? Okay, let's proceed and combine the right-hand side. If you look carefully, 4 times negative 4 times negative 6, we will get our 24. And then we will have our 4a. And then 3 times minus 10, it will be negative 30. And all of this will be divided by 3. Okay, let's write the final step and then start interpreting what is going on here. Remember, the question was, for which values of a will the solution be unique? So let's finalize the solution first, and then we'll comment on how do you see, or how do you restrict such that the solution is unique? How do we make a no solution case? How do we make an infinitely many solution case? Negative 4 over 3. So my 24 minus 30 will be negative 6. So I have negative 6. I have negative 6 plus 4a divided by 3. And then on the other side, I have my 3 minus 30 minus 0, 0. 30 minus 24 will get my 6 plus 5a all divided by 4. Okay. Do we all understand how we got here?
Yes, sir.
Point. So I will focus on the last row. So if on the last row, you find yourself having 0, 0, 0, and then on the other side of the equal sign, you have a number which is non-zero, where our alpha is non-zero. Then this case would be a no solution case. Why is it a no solution? Because all what this means, this last row here, it says 0x plus 0y plus 0z is equal to alpha. Remember, the last row is supposed to help us to find z. So now you need to think carefully why such a case will give you a no solution, especially when alpha is not 0. You need to think logically. There is no z value which we can put and multiply by 0 and get alpha, where alpha is a non-zero number. So that's why when you are trying to achieve a no solution case, you make this part here to be 0, but that one, make sure that it doesn't become 0. Then that would be a no solution case. And then when we want to have an infinitely many solution case, copy the last row again. There's our last row. So when you want to have a many solution or an infinitely many solution case, you want to also make whatever which is on the right-hand side to be equal to 0. So you want to achieve a 0 here, a 0 here, and a 0 here. If this is not 0, you will put in the values which would make that to be 0. But for an infinitely many solution case, even that one must be 0. So this case here is an infinitely many solution. And why is that the case? Just think about it carefully. It is not deep. That equation is 0x plus 0y plus 0z is equal to 0. The last row, remember, it is supposed to help us to find Z. So we need to think carefully. What Z value can we multiply by 0 so that we get 0? And the answer is our Z can be anything. So that's why for such a case, we have infinitely many solutions, because Z can be any number. When we multiply it by 0, we will always get a 0. It can be 50,000, it can be 50, it can be 100, it can be 75. That's why when we have zeros like that in the last row, we have infinitely many solutions. And then let's quickly look at the unique solution case. So for the unique solution case, all what you are doing is you are trying to achieve a 1 here. And for the infinitely many solution, you can have an alpha there, and alpha can be anything. Can be anything. Our alpha can be anything. But here, as long as we have a non-zero number, as long as that is non-zero. So now let's take our matrix, our understanding of this, and focus on the last row and give them a solution which will give them the unique solution. So let's paste that. I'm missing a 4 down there. I'm missing a 4 here. So if you look carefully, what we can easily do here is to make this to be equal to 1. Then when it is equal to 1, then we will have a unique solution. In fact, it can be any number. So let's take that and equate it to 1. So let's say our 6 plus 5a over 4 is equal to 1. And then when we solve, we will have our 6 plus 5a is equal to 4. And then we transpose, we have our 5a, it will be equal to 4 minus 6, which is minus 2. And then our a will simply be negative 2 over 5. So when our a is negative 2 over 5, we'll get a 1 here. And as long as we have a 1, whatever which is going on the other side, it does not matter. It can be anything. We all understand what we are doing here. And this would be the unique solution case. So let's say they were saying find a no solution case. So for a no solution case, what we know is that you are supposed to have a 0 there. And here you are supposed to have alpha, where the alpha is non-zero. So for a no solution case, what we would do is we would take that 6 plus 5a over 4 equals 0, and then we would have 6 plus 5a equals 0, and then our a would simply be negative 6 over 5. So I have now made that to be 0. I need to check if that right-hand side will be non-zero for this a value. So I'm looking at the right-hand side. It will be negative 6 plus 4 into negative 6 over 5 divided by 3. And as you can see, this is a non-zero value. So meaning for a no solution case, we would need to have my a equals that. And then achieving an infinitely many solution case here would not be possible. Do we have anyone who is confused here? So what I wrote for you here is very important. This here, that there, which I'm highlighting in pink, and that there, which I'm also highlighting in pink. Do we have anyone who has a question? So let's see what their A is. So they're saying the answer is for all values except that. So let's come here and think carefully what is going on. There's our negative 6/5. So let's come in here and think of what they did there. Do we have anyone who has a question? So this here would make us to have a 1 there. But then the question is it the only solution? We need to think carefully, because any number can sit here. Any number can sit there as long as we do not have that number as what you call as a 0. So this here would give you a no solution if we make that part to be 0. So the only case where that is going to be 0, which would be a no solution, is when this is the case. But remember that when you are solving 1, let me say 0, 0, 0, 1, 1, and 0, 0, what we have here, let me say A1, A2, and A3. What we have here can be any number, and we can easily make it to be 1 by dividing by the number itself. So the only thing we do not want essentially there is a 0 for a unique solution. We do not want a 0 there. And the only way, or the only time when we are going to have a 0 is if our A is equal to that. So in fact, we can expand our solution. Instead of trying to always achieve a 1 here, we can actually have any number there, as long as the number is not the A value, which will end up, as long as when we insert the A value, we don't get a 0. So that's why they said their A is, so essentially the answer is any A, because any A value will give us numbers there, except our A is equal to -6/5. And the reason is because the -6/5 is the no solution case. Do we all understand? We understand what we are doing. Okay, so that's why the answer is that it will be unique for all except that, because the system at -6/5 will have a no solution, as we explained. And then for B, they're saying use Crammer's rule to solve for x3. So let's quickly come, they're saying our A is -1, they gave us for B. So I'll take the system of equations, which is in matrix form, and go ahead and solve the problem. We are looking at B, and you all should be able to do Crammer's rule. So they said, use Crammer's rule to solve for x3 given that our A is -1. So let's paste the matrix and then start doing the work. So I'll substitute my A is -1 below, and have 1 minus 3, and then 3, 2, minus 1, and then 0, 4, 0, and minus 3. We have 4 minus 2 and a 0 there. So if you all remember what Crammer's rule is, this is the column for x3, that is for x2, and that is for x1. So if you remember what Crammer is saying, for our x3, it will be equal to. So Crammer is saying you go to the column of what we are looking for. So we are looking for x3. I will cancel that out. Then the column which describes the value I'm looking for, I will replace it with what is after the equal sign. So meaning I'll take that and then put it there. Because I'm looking for x3, I will scratch the column for x3. So that means my matrix, I'll put in straight lines because we need to find the determinant. It will be 1 minus 3. And then I replace my x3 column by a 4, minus 2, and 0. The other ones remain as they are, 2 and a 4. And then I will divide by the determinant of the original matrix. The original matrix is the one which has the 1 minus 3, and then a 3, a 2 minus 1 is 0, a 4, 0, minus 3. Do we have anyone in the meeting with a question on how we performed this Crammer's rule operation? Anyone? Okay. These straight lines, be reminded that they are for the determinant. So you should be reminded of how we find the determinant of a 3 by 3 matrix. Let's go ahead and find the determinant of the numerator. Then we'll plug back at the end. So if you remember, when we are looking for the determinant, the first thing which we must have on our page is our sign matrix. Our sign matrix, if you recall, it is plus, minus, plus, minus, plus, minus, and then plus, minus, plus. If you remember how we find the determinant of a 3 by 3 matrix, we choose a row or a column, which we will use to traverse. And when you are finding the determinant, choose the row or column with many zeros. Because that makes your life to be easy. So when I'm doing my determinant, I'm going to choose row 3 to do my determinant. So my determinant of that matrix, which I will call, I'll just copy and paste it there, but make it to be a bit smaller. So the determinant of this matrix will be equal to. So since I'm using row 3, it means I'm just going to traverse over the column. So I can see that where I'm intersecting the green and the pink line, my sign matrix is saying there should be a positive. So meaning I'm going to put positive and then the number which is there, which is a 4, and then I'm going to take the determinant of what is left, which is minus 3, 4, -1 and -2. Okay, then remember we need to traverse. So there's no need for me to traverse along my row because when I go there will be a 0 which will multiply everything, just like the 4. And then when I go here, there will be a 0 which will multiply everything. I hope that makes sense. What I mean, in case you do not see it, is that I look at my sign matrix, it is saying I need a negative there, but the number which is there is a 0. Then I find the determinant of what is left after crossing, which will be 1, a 4, a 2, and -2. So the reason why we choose a row with many zeros is because, look, wherever I see zeros, I know there's no need for me to compute that. Even when I go to the last one, do that, and I see my sign matrix is saying I need a positive, I will go on and put in a positive, but I have a 0. So whatever which is going to multiply 0 does not matter. So which means the only part which is playing a role is that first part there. So let's find that determinant. I need you to remember that the determinant of a 2 by 2 matrix A, B, C, D is given by my AD minus CB. So if you look carefully, my determinant of the top matrix will be 4 into -3, multiply that, and then minus that, multiplied that. So -3 times -2, we will get a 6, and then minus 4 multiplied by -1, which will just be 4 into, if you look carefully, it will be 6 plus 4, which will be 10, so we have 40. We have 40 as the determinant of the top part. So that whole matrix will end up being 40. Okay. Then let's deal with the bottom part, because after we find that, we just divide the 2, and that's our answer. So let's find the determinant of the denominator. Okay, so which row should we take here, or column? Anyone? Anyone in the meeting? Which row or column should we take? Anyone? Let's use rule 2. So what should I put in after the equal sign? Yeah. Anyone? Anyone who has a question, please ask.
So,
Yes.
can you re-explain the thing at the end part, the last determinant? So, since we don't have a row that has 2 zeros, we can choose any row that we want.
So I choose the row which has many zeros. So in this case, the many zeros is just 1. Do you see that? And the reason why I choose a row which has many zeros is because where there's a 0, I don't need to perform the operation where I cross and then whatnot, because when I come and cross here, I will have a 0 multiplying everything, which shall be the determinant, which is I'm going to have. So that's why I choose the row, the column which has many zeros, because my job becomes easy.
Okay.
Do you understand?
Yes.
Okay, no problem. So the determinant, which, if you remember, this was the denominator. This was the denominator, it became -3. If you remember, the determinant of the numerator was 40. So that's why our x3 should be -40/3, which is exactly what they are expecting us to find. So please make sure that you are able to do Crammer's rule. It is very easy. If, for example, they were saying we should look for x2, I'll take this matrix here and then show you, and then I pause. So let's say they were saying solve for x2. For x2. So we'll paste this matrix here, and then look at what we will do. So I go to x2 because I'm solving for it. I scratch it out. Okay. And then I take what is after the equal sign. It should go and sit where x2 was. So which means my x2 will be the determinant of 1, 2, 4. And then I replace the column of x2 with what is after the equal sign, which is 4 minus 2, 0. And then the x3 column remains the same, 0 minus 3. And then we always divide by the determinant of the original matrix. And that there is the original. So we only change the top part depending on what we want to find. So the original always goes below. And luckily enough, from the previous calculation, we have found the original. We saw that it is going to be -3. So I'll have 1 minus 3, and then 3, 2 minus 1, 0, 4, 0, minus 3. So I need to deal with the top part, because the bottom part, we already found that it is -3. Calculated it previously on the previous page, which is here. That's the denominator. So the numerator is changed because we are solving for something different. So let's take the numerator and paste it here and start solving for it. But let me take it to the next page. And remember, I said to you, the first thing you need to have when you're looking for your determinant is your sign matrix. The sign matrix has plus, minus, plus, minus, plus, minus, plus, minus, plus. So we'll choose a column or row with many zeros. So we'll just choose column row 2. It has 1 0. Column 2 also has 1 0, so there's no advantage really. So let's choose column 2. Row 2, sorry. The determinant of that matrix there will be, I'll start traversing because I chose row 2. So I start cancelling. So where there's a cross, my sign matrix is saying I need a negative. Then I'll put the number which is there, then the determinant of what is left, which is 4, 3, 0, and minus 3. Okay, and then we'll put in a plus. The sign matrix is saying I need a plus, so I already have the plus. Then I need to put in the number. Let's go in, I need to